we're going to solve radical equations. And we have to be very careful solving radical equations because we could get extraneous solutions. So we need to make sure we look for those. And so always, 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 always check your answers. Make sure you know you've done it right. And so what we're going to look at is, suppose that we have the equation the square root of 4x plus 1 equals 5. Well, what we need to do is get the x by itself, but the x is currently trapped inside of the square root, so we got to get it out. Now remember when we rationalized, we said we could either square to get rid of the square root, or we can multiply it by itself. In this case, since I have an equation, as long as I do something to one side and I do the same thing to the other side, then it gives the same equation under the assumption that you can actually do it. So this is where you have to go back and check your answers. So when we square a square root, we just get the radicand, which is 4x plus 1, and that's going to equal 5 squared, which is 25. We then solve this like any other equation to get 4x equals 24, divide by 4, and we see that x equals 6. So we need to make sure that we've done this right, so we check our answer. So does the square root of 4 times 6 plus 1, does that equal 5? Well, 4 times 6 is 24. 24 plus 1 is 25. The square root of 25 is 5, and sure enough, 5 equals 5, and so we get x equals 6. And notice that only worked because we returned the positive root of 25. And that's where the issue comes in. A lot of times you'll find that it would work if you had control over the sign, but since it always returns the positive, you have to make sure you check it against something that's always the positive. Okay? Let's look at our next example. Suppose we have the cube root of 3x minus 12 plus 4 equals 1. So here, this plus 4 is in our way, because I don't have the radical all by itself, and I don't ever want to deal with squaring a perfect square trinomial with a radical unless I absolutely have to. So what we're going to do is we're going to subtract 4 from both sides. So now the cube root of 3x minus 12 equals minus 3. Well, now we need to get rid of the cube root, and we do that by cubing. And that gives us 3x minus 12. So when we cube a cube root, it goes away. And minus 3 cubed is minus 27. And now we solve it like we do everything else. We add 12 to both sides. 3x equals minus 15. Divide by 3. You get x equals minus 5. So now we come back and we check our answer. We get the cube root of 3 times minus 5 minus 12 plus 4 equals 1. So 3 times minus 15 minus 12 plus 4 equals 1. 3 times the cube root of minus 27 plus 4 equals 1. Cube root of minus 27 is minus 3. Minus 3 plus 4, sure enough, is 1. So since that work checks out, we know that this is our answer. So now you're probably wondering, why is it that we have to check our answers? Well, let's look at the following problem. Suppose we have 3x minus 5 plus 8 equals 3. Okay? We want to get the radical by itself first, so we subtract 8 from both sides. Get a square root of 3x minus 5 equals minus 5. So we square both sides to get rid of the square root. And so 3x minus 5 equals positive 25. Well, this lets us add 5 to both sides. So 3x equals 30, divide by 3, and x equals 10. So let's go back and let's check 10. So we get the square root of 3 times 10 minus 5 plus 8 equals 3. Well, that's 30 minus 5 underneath the radical plus 8 equals 3, which is square root of 25 plus 8 equals 3, which is 5 plus 8 equals 3, which is 11 equals 3, and that doesn't work. And why doesn't it work? Because right here we had a negative 5 in order to go any farther. And when we squared it, it became a positive 25, so we found it as if we were solving for a positive 5 there. And so we don't get an answer, and we have to cross this guy out. He's not part of our answer, and since there's nothing left, we say there's no solution, or a 0 with the line through. So make sure you check your answers to look for those. And again, make sure you don't create any perfect square trinomial.